All right, so here we go with our last section of Unit 8, which is logarithmic function graphs. And we're going to use this idea of logs and exponents being inverse functions, that they undo one another to be able to graph log functions. Okay, so I want to show you a little bit about that. So remember when we talked about inverse functions, we talked about if you know the original function and have a table of values for it, you can find the new function by just swapping those values, right? So we're going to use that idea here. If we want to graph y equals log base 2 of x, all we have to do is look at what that little base is, and we can use the exponential form of that base to help us graph it, okay? So here's what that looks like. We're going to start, excuse me, with 2 to the x power, because 2 to the x is the exponential base that matches log base 2, right? As long as the bases are the same, we can use them. So we're going to go ahead and plug in these exponents so we can get a good picture for this, and then we'll use that to help us get a good picture for the log, okay? So if I plug in 2 to the negative 3, either on a calculator, just by working it out in your head, I should get 1 over 8. 2 to the negative 2 power is going to be 1/4. 2 to the negative 1 power is 1/2. 2 to the 0, or anything to the 0, is 1. 2 to the first power is 2. 2 squared is 4. And 2 to the third is 8. Okay, so we have our exponential points. Let's go ahead and graph it, just remind ourselves what exponential functions look like. So at negative 3, we're at 1/8. Negative 2, we're at 1/4. Negative 1, we're at 1/2. 0, we're at 1. 1, we're up at 2. And 2, we're up at 4. And 3, we're up at 8. So this should look mildly familiar, right? So this is what our exponential function looks like. And exponential functions, excuse me, have horizontal asymptotes, right? Because remember, our y values are coming down and getting smaller and smaller and smaller and smaller and smaller and smaller and closer and closer and closer to 0, but not touching or crossing. So it's where those y values get smaller. They're going smaller in this direction, right? So this is the direction that our function is going to be approaching our asymptote, right? So we can see here that as these get smaller and smaller and closer, what they're approaching is actually 0. So I could write in my horizontal asymptote here, and this is how I like for y'all to do it on worksheets, is to show it with a dotted line. So here we have an asymptote at y equals 0. Right? And I'm going to go ahead and just state domain and range. Remember the domain here, this is going to keep going left and right. So our domain is negative infinity to infinity. And our range, well, when we go down, we hit our asymptote, right? This function can't go any lower than 0. And it's never going to equal 0, so we use a parenthesis. Okay, so this is all stuff we've done before, right? We've done exponentials. We know where their asymptote is. We know how to find domain and range. What we're going to look at today is using the exponential form to help us graph a log function. So because I know these are inverses, I can go from the exponential form to its inverse function form, the log form, by just swapping all the variables. So when I swap, my first ordered pair, instead of negative 3 1/8, is going to be 1/8 negative 3. Instead of negative 2 1/4, we're going to have 1/4 negative 2. Instead of negative 1 1/2, we're going to have 1/2 negative 1. Instead of 0 1, we'll have 1 0. Instead of 1 2, we'll have 2 1. And instead of 2 4, we'll have 4 2. And instead of 3 8, we'll have 8 3. Okay, so now we have a table for our log. So we're going to go ahead and graph these points and see how that changes our shape. Okay, so at 1/8, well, 1/8 is just barely past 0. I'm going to be down at -3. At 1/4, which is not much further past 0, I'm down at -2. At 1/2, I'm at -1. At 1, I'm at 0. At 2, I'm up at 1. At 4, I'm up at 2. And at 8, I'm up at 3. So we're going to go ahead and connect our dots. And you can see this shape is the same. Remember when we did inverse functions, swapping our x's and y's does not really change our shape. What it does is it creates a mirror image across the identity line. So remember, the identity line is this line that goes straight through where all of our x and y values are the same. So you can see that this exponential, if I were to flip it across, I would end up with this log function, right? Or if I were to take this log function and flip it across that line, I would end up with this exponential function, okay? So let's think about what that does to our log. Notice on our exponential, we saw that our y values were getting smaller and smaller and smaller, which led up to an asymptote. So if we swapped them, notice now it's going to be our x values that are getting smaller and smaller and smaller and approaching an asymptote. So if my x's are getting smaller, notice here we're going from 1 to 1/2 to 1/4 to 1/8. We're getting closer and closer and closer to this y-axis, right? And the y-axis is where x equals 0. So I'm going to go ahead and put in my new asymptote here, which is going to be, whoops, I misspelled it, asymptote at x equals 0, okay? So now that we have a log function, because we swapped our x's and our y's, notice we went from a y equals 0 asymptote to a x equals 0 asymptote, okay? The other thing that changes is now that our x's are the one that have that invisible barrier that we can't cross, now it's going to be our domain that has a restriction. Because if I look at this green function and I think about how far to the left can it go, well, it's not going to be able to cross this invisible barrier of that asymptote. So it's going to hit at x equals 0, right? It can't go any further than that. But it's not going to touch or cross 0 because it's an asymptote. So we can't include 0. But then going to the right, it can go off as far as we want it to. So to infinity. Okay. And then our range, conversely, has no bound, right? This can keep going down as far as we want, and this can keep going up as far as we want. So our range is -infinity to infinity. And remember, we got this by switching our x's and our y's. So notice what happens is our original domain becomes our range, right? And then our range becomes our domain, because wherever our problem was before, it's flipped to now the opposite variable. Okay. All right. So we're going to look at one more of these. This was just demonstrating a log base that's larger than 1. So now I want to look at a log base that is between 1 and 0. So let's look at this one. So if I want to graph log base 1/2 of x, okay, again, all I do is identify what that little base number is, and I'm going to start with the exponential form of that base number. So we're first going to find a table for 1/2 to the x power, and then we can use that table and swap it to get our log, okay? So let's go ahead and fill in. 1/2 to the -2 power is 4. 1/2 to the -1 power is 2. 1/2 to the 0 is 1. 1/2 to the 1 power is 1/2, and 1/2 squared is 1/4. So I'm going to go ahead and graph this just so that we can see what it looked like as an exponential. So at -2, we're up at 4. -1, we're up at 2. 0, we're up at 1. 1, we're at 1/2. 2, we're at 1/4. So you can see it does have that nice exponential shape where our y's are getting smaller and smaller and smaller and approaching something, right? So we can see here as our y's get smaller and smaller, this is where our asymptote will be, right? Which is down here at y equals 0. So if the y's are getting smaller and smaller and smaller, we should have a y asymptote. So here we have an asymptote at y equals 0. Okay. And again, we can state our domain and range. Our domain, this is going to keep going left and right, so negative infinity to infinity. And our range, it gets stopped at this horizontal asymptote. It can't go any lower than 0. So our lowest is 0, but not included, so parenthesis, and then our highest is going to be infinity. Okay. So again, this is what we did when we talked about graphing exponentials, right, before we got into transformations. So now we want to use this exponential table to come up with our log table. So we're just going to go ahead and swap all of our variables. So now we're going to get the point 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. All right, so now that we have those points, let's go ahead and graph them. At 4, we're down at -2. Sorry, ignore that one. 4, we're down at -2, not +2. 2, we're at -1. So 2, -1. 1, we're at 0. 1/2, we're up at 1. And 1/4, we're up at 2. So you can see we get this nice log shape. And just like before, it is reflective of our exponential over this identity line, right? And I can draw that in, put my pen away. So if we look here at this identity line, y equals x, you can see that the exponential, if I flip it across here, I would end up with this log function, okay? So our y's were getting smaller and smaller and smaller on our exponential, which gave us a y asymptote. This time our x's are getting smaller and smaller and smaller, which is going to give us an x asymptote. So notice these x's are getting smaller and closer to this x value of 0, which is at our y-axis, right? So we're going to go ahead and say this gives us an asymptote at x equals 0, which is going to affect our domain, right? Now our domain can't go past into the negatives, right? So it's going to start at 0, and then this function can go as far as it wants out to the right. Range is unaffected, right? It knows no bounds. So this can keep going down, this can keep going up. So again, notice a y asymptote at 0. When we swap all of our variables, we then get an x asymptote at 0. Our domain, which was unlimited, becomes our unlimited range. And our range that had a bound becomes our domain that has a bound. Okay? So here's where we go from here. Now that we know how to get this basic log function table, now we want to do transformations. So HSRV, right? Left, right, up, down, stretch, reflect. So we're still going to do it in our HSRV order. The only difference is, in order to come up with our log table, we first have to identify the base, use the exponential form of it to get an exponential table, and then swap it to get our log table. And then once we have our log table, then we just modify it like we always done. Okay, so let's go ahead and look what that looks like. If we are given a function that looks like log base a of x, remember we have to be able to see what's going on inside the function and outside the function so that we know if it's being done to the x variable or the y. So anything that happens inside these parentheses is going to affect the x. Okay, so if it's inside the log, we know that it's affecting the x. If it's outside the log, so if it's out front or if it's out of our parentheses, that's when we know that it affects the y. Okay, so looking at location is everything, right? So if it's outside of the parentheses, then we know it's outside the log and affects the y. If it's inside, then we know it affects the x. Okay, so let's go ahead and look at one. So before I worry about tables and all that jazz, I want to go ahead and just identify what transformations have happened by looking at what's inside the function, what's outside the function. So I'm going to go ahead and list my HSRV here. And I can see 3 transformations. Okay, this first one is inside the function. I'm changing the sign of my x. I'm negating it. So if I change the sign of my x's, remember that's a reflection. So if I change from positive to negative or negative to positive x's, that's going to flip it around the y-axis. So this is going to be a reflection about the y-axis, and I get that by changing the sign of my x's. Okay. Then I have this -4. -4 is also inside the function. So if it's inside the function, that's going to be a horizontal shift. Remember, x's are backwards from what we would think. So even though it says -4, that's going to move us to the right 4. And to move our picture to the right 4, we need to go ahead and take our x's and add 4 to them. Okay. And then the last transformation that I see is this -2. And this -2 is outside the parentheses, so it's outside the function, which means it's being applied to the y. So that makes it a vertical shift down 2. So we're going to take our y's and subtract 2 from them. Okay? All right, so now we need to graph it. Now we need a table that we can modify. We can't come up with just a log table by itself for the most basic form of the log without getting horrible decimals and things like that. So we're going to go ahead and start with this base. All we do is look and see what this base is. In this case, it's a 2. So that tells me that I'm going to start with 2 to the x. So whatever that base is, just raise it to the x power, and that will give you the exponential parent. So let's go ahead and start with 2 to the x power. And I'm going to plug in the same numbers we always do, -2, -1, 0, 1, and 2. And I'm going to plug them in. When I plug these in and apply it to the exponent of the 2, I'm going to get 1/4, 1/2, 1, 2, and 4. Okay. Now, this is the exponential form. Remember, what I want to graph is the log form. So before you start doing your transformations, let's go ahead and swap this to a log base 2 of x table. Okay. So I'm going to take all my values and just swap them, okay, to go from this table to this table. So now I'm going to have 1/4 -2, 1/2 -1, 1 0, 2 1, and 4 2. So that took us from exponential to log. So now we can see what our log parent function is. And you can go ahead and graph it if you just want to see what it looks like to begin with. Okay, it should give us something like this. And then we're going to transform it by doing a table for each transformation. So the first one is to go right 4. So I'm going to go ahead and write these out. Log base 2 of x minus 4. That's going to be my first transformation. And then I'm going to reflect about the y-axis. I'm going to go ahead and just write out my table so I can make sure they fit, and then we'll do the actual transformations. So the next one is my reflection. So that would be log base 2 of -x minus 4. And then I do my vertical shift down. So then I have log base 2 of -x minus 4 minus 2. All right, and I ran a little bit into my graph. Whoopsie. All right, so let's look at these. To do my horizontal shift to the right 4, I'm going to take my x's from the previous table and add 4 to them. So 1/4 plus 4 is 4 1/4, or 4.25, however you feel more comfortable writing it. 1/2 plus 4 is 4 1/2. 1 plus 4 is 5. 2 plus 4 is 6, and 4 plus 4 is 8. Okay, my y's stay the same. I didn't do anything to them. Okay, so that's my horizontal shift. Now I do my reflection. My reflection says that I want to negate or change the sign of my x's. So I take my x's from the previous table and just change their sign. So that's going to make this a -4 1/4. A -4 1/2, a -5, a -6, and a -8. My y's stay the same. So -2, -1, 0, 1, and 2. Okay, and then my last transformation table is my vertical shift to go down 2. So I'm going to take my y's from the previous table and just subtract 2 from them. Okay, and I know y'all have a whole bunch of paper. You could be writing this down here. I'm just writing it up here so I don't have to keep scooting my paper up and down. Okay, so if you don't like to write this small, that's okay. Just use your other paper. Okay, all right, so when I move this down 2 minus 2 is -4. 2 minus 1 is -3. 0 minus 2 is -2. 1 minus 2 is -1. 2 minus 2 is 0. And then my x's stayed the same. -4 1/4, -4 1/2, -5, -6, -8. Okay, so now that I have my function looking the way that I want it to, now I'm just going to graph these points. Notice I can see where my x's are getting smaller, right? This is my bigger, or sorry, this is, or not getting smaller, but approaching something, let's say, approaching something. So they go from -8 to -6 to -5 to -4 1/2, -4 1/4. It's probably going to be -4 and something smaller, -4 and something even smaller than that. So I'm thinking my asymptote is going to be somewhere around -4. Okay, so let's go ahead and graph it. So at -4 1/4, that is just barely past -4. At barely past -4, I should be down at -4. 1, 2, 3, 4. At 4 1/2, so -4 1/2 is between -4 and -5. So at -4 1/2, I'm going to be down at -3. At -5, I'm at -2. -6, I'm at -1. And -8, I'm at 0. So you can see indeed this is taking a turn, and this is where my x's are clustering up. So notice as I draw this, you can see that they're clustering up really, really close to this x equals -4 line. Okay, so go ahead and draw in your asymptote at that point, or sorry, on that line. And we can go ahead and state that our asymptote is at x equals -4. Okay. All right, and then once I have that drawn, then I can state my domain and range. My domain is going to keep going back to -infinity, but it hits a wall, right? This invisible barrier at my asymptote, which is at -4. And then my y's continue on without bound. So -infinity to infinity. Okay, so the only thing that's different in this section, whoops, from just graphing regular exponential functions is that we first must take that log base and create a table with the exponential form, okay, or the exponential parent, if you want to think of it that way. Then once we have the exponential form, we swap it to get our log form. And then once we're in log form, then we can do our transformations. Okay, when we swap it, we go from a horizontal asymptote to a vertical asymptote. So make sure on any of your log problems or on the worksheet that you have a vertical asymptote, or you know you did something wrong. Okay, all right, let me look at a couple more examples and then I will have y'all try some. All right, so on this first one, and again, if you need more writing space than this, you're welcome to put more paper in or work on the back or whatever works for you. I'm going to go ahead and identify my HSRV shifts. So I see the 2 out front, that's multiplying outside the function. So multiplying outside the function is going to affect my y's. That's going to be a stretch, a vertical stretch. So I'm going to take my y's and multiply by 2. Okay. The +3 on the inside, that is a horizontal shift to the left. So I'm going to take my x's and subtract 3. And then the +1 on the outside is going to be a vertical shift up 1. So up 1 means I need to take my y's and add 1 to them. So we had no reflections on this one. Okay. All right. So let's first identify what our base should be. Notice here, I don't have a little log base. I just have ln. But remember, ln was one of our special logs, right? It's our natural log. And the natural log is the same thing as saying log base e of x. Okay, so anytime you see ln, you should be thinking e. So anytime, I'm just going to circle the ln and say we know that the base is e, so I'm going to start with e to the x as my exponential parent. Okay, so I'm going to come over here and make a table of values with e to the x. Again, -2, -1, 0, 1, and 2 are the numbers I always choose. And when we plug these in, we might have to use a calculator, right? Because E1 is kind of a funky number. And 2, it's going to give us decimals. And so we want to make sure our answer is accurate. So I'm going to use this calculator. If you have a different calculator, that's fine. But your E button should be located somewhere around your log and your ln button. Mine is a second function button on my ln. So I'm going to hit the second and then that ln so that I get e to the whatever power, and I'm just going to plug in -2. So e to the -2 power, make sure you're using this negative button that changes the sign, not the subtraction. Okay, so e to the -2 is equal to 0.13533 blah 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 blah. Now remember, we're using this number to be able to graph the function. So I really don't need all these decimal places to be able to get a good approximation of where this point is. So I'm just going to round to 1 decimal place. I'm not even going to round. I'm just going to write 1 decimal place. So I'm going to put 0.1. Okay, and then plug in the next number. So now e to the -1 power gives me 0.3678 blah 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 blah, lots of stuff. Again, I'm just going to use 1 decimal place so I can get an accurate picture. E to the 0 without using your calculator, right? Anything to the 0 power is 1. Okay. E to the first power is 2.7182818281828, and we're just going to write 2.7. And then e squared, or e to the second power, is going to give me 7.389 and some more stuff. So I'm just going to say 7.3. Okay, so now that we have a good approximation for e, right, our parent function in exponential form, now we need to go ahead and swap it so that we can get our ln x function. Okay, so I'm just going to swap to go from this table to this table. So instead of -2.1, I'm going to get 0.1 -2. Then I'll get 0.3 -1, 1, 0, 2.71, and 7.32. Okay, so now I have my starting log table, and now I can make additional tables to do my 3 shifts. So I'm going to go ahead and write out my 3 tables, and then I'll go back and do the actual shifts. So I'm going to do my horizontal shift, which will make this ln of x plus 3. So I need a table for that one. And then I have my vertical stretch. So now it will look like 2 ln of x plus 3. So I need my table for that one. And then I have my vertical shift. So that will look like 2 ln of x plus 3 plus 1. Okay. Squeezed it in there. All right. So to do our very first shift, which is our horizontal shift, right? We're moving to the left 3. So we're going to take our x's and subtract 3 from them. So I take my x's from this previous table, -3. So 0.1 minus 3, and you're welcome to use a calculator, should give us -2.9. 0.3 minus 3 should give us a -2.7. 1 minus 3 is -2. 2.7 minus 3 is -0.3, and 7.3 minus 3 gives me 4.3. Okay, I didn't do anything to my y's, so they stay the same. Okay, now I want to go into my vertical stretch. My vertical stretch says I need to multiply my y's by 2. So I'm going to take my y's from this previous table and times them by 2. So -2 times 2 is -4. -1 times 2 is -2. 0 times 2 is 0, 2 times 1 is 2, and 2 times 2 is 4. Okay, my x's stay the same. Negative 2.9, negative 2.7, negative 2, negative 0.3, and 4.3. Okay, and then I do my last transformation, which is a vertical shift up 1. So I'm going to take my y's and add 1 to them. So y's from the previous table plus 1. So negative 4 plus 1 is negative 3. Negative 2 plus 1 is negative 1. 0 plus 1 is 1. 2 plus 1 is 3. And 4 plus 1 is 5. Okay, and then all my x's stay the same. So negative 2.9, negative 2.7, negative 2, negative 0.3, and 4.3. So now that my function looks the way I want it to, right, now I'm going to graph this last table and try to figure out where that that vertical asymptote is. So at negative 2.9, so that's almost to negative 3. We're down at negative 3. 1, 2, 3. At negative 2.7, which is a little bit further than halfway between negative 2 and negative 3, I'm down at negative 1. At negative 2, I'm up at positive 1. At negative 0.3, now negative 0.3 is just barely past 0. I'm up at positive 3. And at 4.3, which is just past 4, I'm up at 5. So when I draw my picture by connecting my dots, you can see here that the vertical line that we're getting closer to but not touching is going to be here at negative 3. So we go ahead and write in our dotted line to show where our asymptote is. Be sure you do that on the worksheets and on your exams, okay? So asymptote is going to be at x equals negative 3. Be sure to write the x equals not just negative 3, okay? Because that lets me know if it's a horizontal or a vertical. So be sure it has the variable in there. And then our domain. Furthest to the left this is going to go, well, it's going to hit that invisible barrier at our asymptote, which is at negative 3. And then it's going to continue on out to the right to positive infinity. And then our range on any log function has no bounds. So negative infinity to infinity, because it's going to keep going down and it's going to keep going up. Okay? All right, let me do one more and then y'all have some to try. Okay, so this one again, before I worry about tables and modifying and all that mess, I'm going to go ahead and just figure out what my transformations are. So I'm going to list my HSRV, and I see 3 transformations here. So the first one is the negative out front. If it's out front, it's outside the functions. That means I'm changing the sign of my y's. And if I change the signs of my y's to be negative or positive, that's going to flip it around the x-axis, right? So this is a reflection about the x-axis. And I'm just going to change the sign of my y's, okay? The negative 2 on the inside is a horizontal shift. This is actually going to move it to the right 2, which means we need to take our x's and add 2 to them, okay? And then the plus 5 on the outside is going to be a vertical shift downward. So down 5. And we'll take our y's and subtract 5 from them. So we have no stretching or shrinking on this problem. Okay. All right, so let's identify what our little exponential base is going to be. We look at our log base here, which is 1/3. Okay, so that means we're going to start with 1/3 to the x power. Okay, whatever the base is on the log, that's the exponential base we start with. So I'm going to come down here and start with 1/3 to the x power. Again, I'm going to plug in -2, -1, 0, 1, and 2. When I raise 1/3 to the -2 power, I get 9. 1/3 to the -1, I get 3. 1/3 to the 0 is 1. 1/3 to the first power is 1/3. and 1/3 squared is 1/9. Okay, so that gives me my exponential starting table. Okay, but remember, we want to do logs, not exponential. So now let's go ahead and swap it so we get log base 1/3 of x. Okay, so going from here to here, we got to swap. Okay. So now we have 9, -2, 3, -1, 1, 0, 1/3 1, and 1/9 2. Okay. So remember, the starting point, our asymptote is going to be at 0. The only thing that's going to change our vertical asymptote is if we move our function to the left or right. Okay. So let's go ahead and start doing our transformations. And I'm actually going to list out the tables like I did on the last one, and then I'll fill them in. So horizontal shift is going to make this look like log base 1/3 of x minus 2. And then we have our reflection, which makes it look like negative log base 1/3 of x minus 2. And then we have our vertical shift down 5. So now it looks like negative log of 1/3 x minus 2 minus 5. Okay. All right. So I have all of our shifts written out. Now we just need to modify our tables. So going from our basic log table to doing our H, right? H, S, R, V, okay? To do our horizontal shift, which is right 2, we're going to add 2 to our x's. So I take the x's from the previous table and add 2 to them. So 9 plus 2 is 11, 3 plus 2 is 5, 1 plus 2 is 3, 1/3 plus 2 is 2 1/3, and 1/9 plus 2 is 2 1/9. My y's stay the same because I didn't do anything to them. So -2, -1, 0, 1, and 2. And then I go ahead and do my next one, which is my reflection, which says that I need to change the signs of my y's. So I take the y's from my previous table, change their signs. So I end up with +2, +1, 0, -1, -2. And my x's stay the same. 11, 5, 3, 2 1/3, 2 1/9. Okay. And then my last shift is my vertical shift down 5. So I subtract 5 from my y's. So I take the y's from my previous table and subtract 5. 2 minus 5 is -3. 1 minus 5 is -4. 0 minus 5 is -5. -1 minus 5 is -6. And -2 minus 5 is -7. Okay. X's stay the same. 11, 5, 3, 2 1/3, 2 1/9. And notice this one is actually off my graph. I can't graph 11, -3, so I'm just going to start on this second point. So at 5, I'm down at -4. At 3, I'm down at -5. At 2 1/3, so barely past 2 a little bit, about 1/3 of the way, I'm down at -6. And at 2 1/9, I'm down at -7. So you can see where my x's are all clustering up is right here, right? As this comes, this would be out at 11. So I'm going to do something like this. You can see what they're getting closer to and not touching is this line right here at x equals 2. So I'm going to go ahead and draw my asymptote in on top of that line with a dotted line. Say that my asymptote is at +2, which means that my domain starts at 2 and goes out to infinity. And my range, as always, is -infinity to infinity. Okay, so notice on both of these examples, my asymptote had a lot to do, with my shift, right? This one inside, when I moved left 3, that took my asymptote from 0 over to -3. Same thing on this next one. I had a -2 on the inside, which took me to the right 2. So I started at 0, I moved to the right 2, which put my asymptote at x equals 2. So that's just a little hint to kind of help you figure out where your asymptote should be if that's something that you're struggling with, okay? All right, so on the next couple of pages, there are 3 for y'all to try. So I'd like for you to go ahead and pause the video and try those. If you get stuck or if you finish and are ready to check yourself, go ahead and play the video and we'll go over it and see how you did. All right, so on number 1, because it's an ln, we're going to use base e to do our exponential. So we'll make our exponential table with e to the x. Then before you start doing your transformations, swap those values to get ln x. And then you should have 2 transformations, one that reflects about the y-axis and one that moves up 6. So we should be changing the sign of our x's and then adding 6 to our y's. Okay, that puts our function up here with a vertical asymptote at x equals 0. Make sure you write x equals, not just 0. And our domain would be negative infinity to 0, and our range is all real numbers. Okay, if you need more time to look at that, go ahead and pause it, but I'm going to go ahead and go on so that I can go over number 2 and number 3. Okay, so for number 2, okay, we see here that our log base is 3, which means we're going to start with 3 to the x power. So we make a table with 3 to the x, and then we swap it to get log base 3 of x. Once we have our log base 3 of x, then we should have 2 transformations, left 4, down 2. We do them in HSRV order. So we're going to do our horizontal shift first by subtracting 4 from our x's, and then we'll do our vertical shift down by taking our y's and subtracting 2. So our function should look something like this, where our x's are approaching negative 4. So our asymptote is x equals negative 4, which means that our domain starts at negative 4 and goes on out to infinity, and our range, again, all real numbers. Okay, if you need more time, pause it so you can look at it, but I'm going to go ahead and go over number 3. Number 3, we look at our base. Our base number here is 1/2. So we're going to start with 1/2 to the x power. So 1/2 to the x power gives us our exponential parent function. Then we swap the values to get our starting log function. And then we're just going to adjust for the transformations that we have. And here we have 3 transformations. We have a horizontal shift left 2. And then because of the negative that's inside, or sorry, in front of the log here, and inside in front of the x, we have both types of reflections. So reflection about the x and the y-axis, which means we need to change the signs of both the x's and the y's, okay? So starting with this log table that is our parent, we're going to start in HSRV order. So again, starting with our horizontal shift. So we're going to subtract 2 from our x's to move it to the left. And then for our reflections, now since both of these are reflections, and reflections is the third thing that we do, I'm okay with you doing them in the same table. If you wrote it out as, you know, a table for the y reflection and a table for the x reflection, or vice versa, that's totally fine. I went ahead and just did mine together. So going from my horizontal shift over to my reflections, I went ahead and changed the signs of all my x's and all my y's in one step. Okay, so that puts our function up here, and our asymptote would be at x equals 2, which means that our domain can go from negative 2 up to that asymptote at 2. And again, our range is all real numbers. So that is the end of this section. If you need more time on number 3, go ahead and pause it. But other than that, you should now be able to complete this assignment in your Alto Knewton homework, which is logarithmic function graphs. There is also a worksheet that goes with this section, okay? And I'm grading the worksheet exactly like I did the problems in class. Did you list out your HSRV? Did you show your parent table as an exponential function and then swap it and then modify one table for transformations? Okay, and then did you draw in and state your asymptote along with plotting your graph? So be sure you work your worksheet following the format that we did in this lecture video so that you don't miss points. Okay, all right. So y'all have at it. And if you have any questions, please let me know.